The planet did not always behave the way it does today. There was a chapter in Earth's history when the rules felt loosened, when heat lingered longer, when forests grew denser than light itself, when size stopped being a disadvantage and quietly became a weapon. This was a world where limits blurred, and in that world, some animals did not just grow larger, they grew unnaturally large. Imagine standing in the tropics of an ancient Earth. The air is heavy, thicker than modern air. Heat does not fade at night. Rain does not refresh. It accumulates. Rivers swell and refuse to retreat. Swamps stretch for miles. Vegetation piles upon vegetation, layer after layer, trapping warmth close to the ground. This is not a hostile environment. It is an indulgent one, and evolution responds to indulgence differently than it does to scarcity. In harsh worlds, survival favors speed. In unstable worlds, it favors intelligence. But in worlds like this, survival favors mass. Most animals live their lives negotiating limits. How big can I grow before I starve? How heavy before my body fails? How slow before I'm caught? But in extreme heat, something subtle changes. For reptiles, creatures whose bodies depend on external warmth, heat is not stress, it is fuel. Constant warmth accelerates digestion. It shortens recovery time. It allows muscles to remain active for longer periods without fatigue. Growth no longer carries the same penalty. And slowly, generation by generation, bodies begin to stretch past familiar boundaries. The fossil record from this era tells a strange story. Turtles grew shells thick as stone. Crocodilians reached lengths that rivaled modern boats. Fish expanded into armored giants of slow, unstoppable motion. Nothing rushed, nothing needed to. Predation became less about pursuit and more about inevitability. And somewhere within this overheated world, one lineage responded more dramatically than all the others. A lineage without limbs, without armor, without venom. A lineage built entirely on muscle. Snakes are not designed for size. They have no legs to support weight, no rigid skeleton to brace mass, no lungs paired for redundancy. Every increase in length strains their physiology, which is why, in modern ecosystems, large snakes sit close to a ceiling they cannot cross. Yet during this ancient interval, that ceiling lifted. Water-supported environments reduced gravity's toll. Prey animals grew larger and slower. Competition thinned. The snake body, normally constrained, found space to expand. And it did, quietly, relentlessly. These snakes did not hunt the way modern predators do. They did not sprint. They did not leap. They did not rely on speed. They waited. In flooded forests and slow-moving rivers, their bodies blended into the environment itself. What appeared to be a fallen log was not wood. What seemed like a shadow was muscle. When contact was made, there was no struggle, only pressure. Bone does not break loudly under constriction. It fails silently. But evolution never offers gifts without debt. Extreme size creates dependence. Dependence on stable heat, predictable prey, unchanging environments. Remove even one, and the entire strategy collapses. Large-bodied reptiles cannot adapt quickly. They cannot migrate easily. They cannot recover fast. Their dominance is overwhelming, but brittle. And the planet, as it always does, began to shift. Temperatures cooled, imperceptibly at first. Rain patterns altered. Forests fragmented. The world that once rewarded mass began to favor efficiency again. And the giants, across many species, started to disappear. Not all at once, not dramatically, but permanently. Yet among all these vanished forms, one creature would later emerge from the deep past to redefine what we thought snakes were capable of. Not as a legend, not as myth, but as evidence. And when scientists finally encountered it, the scale of the discovery forced a terrifying realization. The Earth had already done this once, and it had done it without hesitation. For millions of years, this oversized world left no witnesses. The forests collapsed into coal. The rivers buried their own banks. The giants vanished without ceremony. What remained were fragments, compressed, mineralized, silent, until one discovery forced scientists to confront just how far nature had once gone. Deep beneath layers of ancient rainforest debris, paleontologists uncovered vertebrae that immediately felt wrong. Not damaged, not distorted, simply too large. Each bone was thick, heavy, and unmistakably serpentine, yet its proportions did not match any known snake, living or extinct. When the skeleton was reconstructed, the implication became unavoidable. This animal had exceeded every known biological expectation for a snake. It was not long by exaggeration, not heavy by guesswork. It was measured. The reconstructed animal, later identified as Titanoboa ceruginoensis, reached lengths exceeding 12 meters. Its estimated mass crossed 1 metric ton. This was not a stretched version of a modern snake. Its vertebrae were thicker. Its muscle attachment points were reinforced. Its body was built to sustain weight over long periods. It was not fast. It did not need to be. It was designed for dominance through presence alone. In water, its size dissolved into silence. On land, its mass dictated the outcome of any encounter. There was no escalation, only compression. Titanoboa did not evolve because it was superior. It evolved because the environment removed restraint. The heat allowed constant metabolic activity. The wetlands supported mass. The prey base eliminated the need for speed. In short, the planet made room, but that room was temporary. As global temperatures declined, Titanoboa's advantage inverted. Its body demanded more energy than the cooling world could provide. Its slow reproduction limited recovery. Its specialization left no escape route. When the environment tightened, the strategy collapsed, and Titanoboa disappeared. Modern snakes still test size, but cautiously. Today's largest species exist at the edge of feasibility. They rely on warm climates, limited competition, narrow ecological niches. They survive, but they do not dominate, because the modern Earth no longer tolerates excess. Seasons interrupt growth, cold limits metabolism, human presence fragments habitats. The conditions that once allowed a snake to grow longer than a bus no longer align, not by accident, by balance. Titanoboa is more than a curiosity. It is a warning etched into stone. Its body size acts as a climate record, proof that the ancient tropics were far hotter than today, proof that when heat rises, limits fall. Evolution does not ask permission, it responds. If environments shift far enough, old strategies return, not because nature remembers, but because physics allows it. We tend to believe that extremes belong to the past, that the Earth has learned restraint. But Titanoboa reminds us that the planet does not design for comfort, only for possibility. When conditions align, life expands to fill them, sometimes beyond what feels reasonable, sometimes beyond what feels safe. Snakes larger than buses were not an anomaly, they were a consequence. Titanoboa does not haunt the present because it might return tomorrow. It unsettles us because it proves that size, dominance, and excess are not myths. They are temporary permissions, granted by climate, revoked by change, and once, long before humans ever watched the forest floor, the Earth gave that permission freely.